11.1 Areas of parallelograms and triangles. If we have a parallelogram, like we do here in this figure, the base is the bottom of the parallelogram, and then the height would be from the opposite side to that base, right? The perpendicular line from the opposite side to the base. So h here would be the height. You could see that line AT is perpendicular to line B. And you want to remember that in a parallelogram, opposite angles are congruent. So to figure out the area of a parallelogram, if we have the base and the height, is just base times height. Okay. So let's look at example number 1. We have the HG is 30 meters, and this line here is perpendicular, and it goes from base to base, right? So opposite side to opposite side. So 18 meters is the height of this parallelogram. So then the area is going to be equal to 18 times 30. And what it really is 18 meters times 30 meters. And so it's 18 times 30 is 540. And something you need to remember is when we have area, it's 18 meters times 30 meters. So the answer is 540 meters squared, right? Don't forget the units, and that area is measured in squares. So let's go ahead and do this one over here. We have our base is 30, and we have this angle here is 15. I'm sorry, this side here is 15. We're given that this angle is 45 degrees. And that's significant because remember, opposite angles in a parallelogram are congruent. So that angle there is also 45 degrees. So this triangle here is a 45, 45, 90 degree triangle. And we need to use that in order to calculate the height of the triangle. Now, if you remember, with the 45, 45, 90 degree triangle, we have a ratio, right? So this is 45, 45, 90 degrees. And so it would be x are the legs, and then the hypotenuse would be x square root 2. And you can verify that by doing Pythagorean theorem. It's x squared plus x squared is equal to hypotenuse squared. And if you go ahead and solve for the hypotenuse, you'll get x square root 2 as your hypotenuse. Right? So we're going to use these ratios to solve for the leg. Right? We're given the hypotenuse of the 45 degree triangle, 45, 45, 90. So we can find x by setting this hypotenuse equal to this hypotenuse. Right? So I'm going to do that here. I'm going to say x square root 2 is equal to 15. So I'm going to divide both sides by square root 2. So I get x is equal to 15 over square root 2. Of course, we can drop this in a calculator, or we can simplify it, right? And we simplify it by multiplying by square root 2 over square root 2. So then x is going to equal to 2 in the denominator. So 15 divided by 2 times square root 2 is going to be, what, 7.5 times square root 2. Okay, so let's see. Is there any way to get the bigger calculator here? No. So I can go ahead and look up calculator. And I'm going to go and put in the 7.5 times square root 2. 10.6 is what I'm going to use. So x is equal to 10.6. So that means our height is equal to 10.6. Right? And now it's easy to find the area because it's just base times height. So my area is equal to 10.6 times 30. So then that is going to be 10.6 times 30, 318. And it's going to be in units or feet squared. right? So you need to remember your 45, 45, 90 degree triangle ratios, because sometimes you're going to need them to figure out the height of the parallelogram, and other times you're going to need your 30, 60, 90 degree triangle, right? And remember, in the 30, 60, 90, the short leg is x, the long leg is 2x, and then the hypotenuse is x square. Oh, I'm sorry, my bad. It's this one is x square root 2, and then the long leg is 2x. Right. So these are the ratios for 30, 60, 90, and then this is 45, 45, 90, and you're going to need these sometimes to solve some of these problems. So anyhow, let's go ahead and work on these exercises. I'll go over them in the next video.